There are two important terminology that is associated with third law of motion: action and reaction forces. Action forces are generally the cause and reaction forces are generally the effect. This is how you can distinguish them. So for example, us pushing the floor and the floor pushing us. So this is your cause and this is the effect, and thus making us pushing the floor as your action force, and the floor pushing us back is your reaction force. Okay, one more example is a rocket pushing the gas out. The rocket pushes the gas out, so the gas coming out or the force exerted on the gas is your action force, and gas in turn pushes the rocket up. That's your reaction force. That's how a rocket moves up, and that's the basic idea of burning something in vehicles. That is a balloon which has air in it. Here the balloon pushing out the gas is your action force, and the gas will push the balloon forward. That's your reaction force, right? So I hope you guys understood which is what. So there is an important observation that we need to keep in mind. Action and reaction forces are always acting on different objects. Please understand, here the action force was on the floor and the reaction force was on the person. Here the action force was on the gas and the reaction force was on the rocket. Here the action force was on the gas. Here the reaction force was on the balloon. So they are on different objects. Acceleration need not be same in both the cases. See, action and reaction in terms of magnitude, they are the same. If you pull two cars and leave it attached with a rubber band, what happens? They will experience the same force. So F1 will be equal to F2 in terms of magnitude. But the acceleration need not be same. See, when you push something, it accelerates. Do they need to accelerate this with the same amount? No. Example, see the gas which comes out of the rocket, it has a very high velocity, but the rocket does not have that much of velocity to begin with. I mean, in comparison, in time it gains, but when the engine switches on, when the propeller is ignited, obviously we can see gases are rushing out, but the rocket is still there. You got it? So let me show this practically. So please have a look over here. I'll be pulling two cars. The car are C1 and C2 with different masses. Clearly M1, the car 1 has lesser mass than M2, and I'm going to pull them 70 centimeter apart. So we need to observe where will they collide. This is yours 35 centimeter, that is the middle. So we need to observe where will they exactly collide. Okay, so please make this observation. So what did we see? When we pulled 70 centimeter apart, they didn't exactly collide in the center. They collided around this line. Is it not? So this line is not 35 centimeter. So clearly the objects accelerated with different amount. So obviously A1 is more than A2 because the car 1 was much faster than car 2. That's why the collision happened earlier. Is it not? So we know that from the second law that acceleration will reduce if you increase the mass, and that's what we saw. So again this idea comes again in your second law, because there are pairs of forces. Whenever you see a force, there are always pairs of forces acting on different objects. If you hit a floor, the floor will exert a force on you and you are exerting some force on the wall, the floor, right? So this is what your action and reaction force are, and you need to understand that acceleration caused by the action and reaction between the two objects need not be same, right? So you can pause and have a look. And please do write. It's not only to look, please do write everything, including the examples.